In this lesson, we'll deal with equations which don't appear to be quadratic in the first sight, but they can be reduced to quadratic equations by making some simple substitutions. And these type of equations are characterized by one term appears to be square of the other term. Like if we exclude the coefficient here, xn is one term and x power 2n is present in the other term. So if we substitute xn equal to y, x power 2n is exactly complete square of y. So let's get started with the solution of such type of equations. And in this example number 1, given equation is x power minus 2 minus 10 equal to x3 times x power minus 1. So here, if we keep x power minus 1 equal to y, then x power minus 2 would be equal to y squared. So let y be equal to x power minus 1. If we take square on both sides, y squared is equal to x power minus 1 power 2. And according to the laws of exponent, if we multiply minus 1 and 2, we will have y squared equal to x power minus 2. Let's make these substitutions in the given equation. So the given equation becomes this will, the x power minus 2 will become y squared minus 10 equal to 3y. This equation is a quadratic equation, so we'll use normal methods for solution of quadratic equations. Let's write it in standard form. So this would be y squared minus 3y minus 10 equal to 0. Let's factorize this, and for this, if we compare it with the standard form a y squared plus by plus c equal to 0, here a would be equal to coefficient of y squared, which is 1, b would be equal to minus 3, and c would be equal to minus 10. As ac is equal to 1 times minus 10, which is equal to minus 10, if AC is a negative number, then we find two such factors of 10 whose sum is equal to 3. And obviously 10 has factors of 1 and 10. It also has factors of 1, 2 and 5. We can take 2 and 5 because their difference is equal to 3, but we cannot take 1 and 10 because their difference is not equal to 3. So the given equation y squared minus 3y minus 10 equal to 0 could be written in the form y squared minus, instead of writing 3, we'll simply write it as difference of 5 and 2. 5 minus 2 is equal to 3. Y minus 10 equal to 0. So this would be y squared minus 5y plus 2y minus 10 equal to 0. And if we take y common from the first two terms, this would be y minus 5 plus 2 common, and inside would be y minus 5 equal to 0. From here we have y minus 5 common, which will give us y plus 2 equal to 0. Now using the zero product property of real numbers, either y minus 5 is equal to 0 or y plus 2 is equal to 0. either y minus 5 is equal to 0 or y plus 2 equal to 0. This means y is equal to 5 or y is equal to minus 2. Now you remember that y was equal to x power minus 1 to begin with. So let's replace that. Replacing value of y, replacing value of y, what we get is x power minus 1 is equal to 5, and here x power minus 1 is equal to minus 2. If this is the case, then 1 over x equal to 5, and here 1 over x equal to minus 2. This means x is equal to 1 over 5, 1 over 5, and this is x equal to minus 1 over 2. So we got the solution for equation which didn't appear to be quadratic in the first place, but we reduced it into quadratic form simply by making a substitution. Now the second equation, which is x power 2 by 5 plus 8. So the given equation now, example number 2. Given equation is x power 2 by 5 plus 8 equal to 6 times x power 1 by 5 plus 8 equal to 6 times x power 1 over 5. So obviously, if you take a look on this term, which involves x power 1 by 5, and you also take a look on this one, this x power 2 by 5 is a square of the x power 1 by 5. So let's make the substitution. So let x power 1 by 5 be equal to y, and taking square x power 1 by 5 power 2, and on the other side y power 2 as well. This means x power 2 over 5 is equal to y square. Let's make these substitutions in equation 1. So let's name it as equation 1. So substituting in equation 1, what we get is y square plus 8, y square plus 8 equal to 6y, which is quadratic equation in variable y, and easy to solve because we have so many methods which we can use to solve this kind of equation. Y square minus 6y plus 8 equal to 0. My favorite method is factorization, but you can use any of the methods which you have learned in the previous questions. So comparing with standard form, here we have a equal to 1, b equal to minus 6, and c equal to plus 8. Since AC is equal to 1 times 8, which is equal to plus 8, so we will find two such factors of 8 whose sum is equal to 6. Since AC is positive, is greater than 0, Therefore we find 2 such factors of AC whose sum is equal to B are 6. So which one are the 2 factors of 8 whose sum is equal to 6? Obviously 2 and 4. So y square minus 6y plus 8. Thus y square minus 6y plus 8 equal to 0 becomes y square minus, instead of writing 6 we will write 2 plus 4 and then y plus 8 equal to 0, and let's multiply y inside, and that will give us y square minus 2y minus 4y plus 8 equal to 0, and regrouping and taking y common from the first 2 terms will give us y minus 2 minus 4 into y minus 2 equal to 0. So this gives us y minus 2 into y minus 4 equal to 0. Either y minus 2 is equal to 0 or y minus 4 is equal to 0. If y minus 2 is equal to 0, then y is equal to 2 or y is equal to 4. Now remember what was y equal to begin with. We made this substitution at an earlier stage and we took y equal to x power 1 by 5. So let's substitute that. X power, this means x power 1 by 5 is equal to 2, and here x power 1 by 5 is equal to 4. If we take power 5 on both sides, so this will give us x equal to 2 power 5, because the power on this side will reciprocate on the other side. So here this will become x equal to 4 power 5. So this is how we can find the solution set, and here 2 power 5 will become 2 times 2 times 2 times 2 times 2, which becomes equal to 32. And similarly, so this is x, value of x, and on the other side this is x equal to 4 power 5, mean 4 times 4 times 4 times 4 times 4. So this would be equal to 256 times 4, and we can certainly multiply this, and this will become 1024, I guess. I don't have a calculator, but that's what my guess is.